Identifying the median class. Welcome, everyone. Before we dive into today's new topic, let's take a quick look back at what we have already mastered. In our previous lessons, we learned how to find the median for ungrouped data. As you remember, that was a straightforward process. You simply arranged your numbers in order and picked the middlemost observation. However, as we move into more complex statistics, we encounter a different challenge. Often, data is organized into what we call class intervals. For example, ranges like 0 to 10 or 10 to 20. When the data is grouped this way, we no longer have a simple list of individual, specific values to look at. Instead, what we have are frequencies, which tell us how many observations fall within each specific range. Now, here is the problem. Because we only know the range and not the exact values of the individual numbers inside those intervals, we cannot immediately pinpoint a single, exact, middle number like we did before. So, how do we handle this? Instead of looking for a single number right away, our first goal is to identify what we call the median class. To put it simply, the median class is the specific class interval that contains that middlemost observation of our entire data set. In the next few slides, I am going to show you the exact step-by-step process you can use to locate this class every single time. Step-by-step process to identify the median class. Now that we understand why we can't simply pick a middle number from a list of ranges, let's walk through the logical, step-by-step process you'll need to follow to find that median class. First, Step 1, you need to calculate the total frequency, which we denote by the letter N. To do this, simply sum up all the individual frequencies, which we call f, from each of your class intervals. In mathematical terms, we say the total frequency N equals the summation of f. Step 2, once you have that total, you need to find the halfway point. You'll do this by calculating N divided by 2. It is very important to remember that this value isn't the median itself, but rather the specific position of the middle observation in your data set. Step 3, next, you must construct a cumulative frequency table. For each class interval, you'll calculate the cumulative frequency, abbreviated as CF. To find this, you take the frequency of the current class and add it to the sum of all the frequencies from the classes that came before it. This creates a running total. Finally, Step 4. This is where you actually locate the median class. You will compare the halfway point we found in Step 2, which is N divided by 2, against the cumulative frequencies in your new table. Your goal is to find the very first class interval where the cumulative frequency is greater than or equal to N divided by 2. In the next slide, we are going to put these exact steps into practice using a real-world example of student test scores to see how this works in action. Real-world example, analysis of student test scores. Now that we have understood the theory and the steps behind finding the median class, let's put everything into practice with a real-world example. Imagine a teacher wants to find the median score of a class of students in a mathematics test. Instead of looking at every single student's individual score, the teacher has grouped the scores into intervals. Looking at our data table here, we have 5 different class intervals, ranging from 0 to 10, 10 to 20, and so on, up to 40 to 50. The second column shows the frequency, which is simply how many students fell into each score range. Our specific goal for this exercise is to identify which of these intervals represents our median class. Let's walk through the solution step by step, following the process we just reviewed. Step 1, we need to find the total frequency, which we denote as N. To do this, we sum up all the frequencies in our table, 4 plus 8 plus 15 plus 10 plus 3. This gives us a total frequency, N, of 40. Step 2, now we need to find the halfway point of our data. We take our total frequency, N, divided by 2, so 40 divided by 2 equals 20. This number, 20, is the position we are looking for. We need to find which class contains the 20th observation. Step 3, this is a crucial step where we construct our cumulative frequency table. We calculate the cumulative frequency, or CF, by adding the frequencies sequentially. For the first interval, 0 to 10, the cumulative frequency is just the frequency itself, which is 4. For the next interval, 10 to 20, we add the previous cumulative frequency of 4 to the current frequency of 8, giving us 12. Moving to the 20 to 30 interval, we add 15 to 12, which brings us to 27. For the 30 to 40 interval, we add 10 to 27, resulting in 37. Finally, for the 40 to 50 interval, we add 3 to 37, which brings our total back to 40. If you look at the completed cumulative frequency table on the slide, you can see all these values clearly laid out. Step 4, now we locate the median class. We do this by comparing our halfway point, which we calculated as 20, against our cumulative frequencies. Let's check them one by one. 4 is less than 20. 12 is also less than 20. However, when we reach 27, we see that 27 is greater than or equal to 20. Since 27 is the very first cumulative frequency that meets or exceeds our target of 20, the class interval associated with this value is our winner. Therefore, our final result is that the median class is the 20 to 30 interval. As we move to the next slide, keep this logic in mind, because it is very easy to make a mistake if you don't follow these steps precisely. Common mistakes to avoid. Now that we have seen how to successfully identify the median class using our test score example, I want to pause and discuss some common pitfalls. Even when you understand the method, it is very easy to make small errors that lead to the wrong answer. Let's look at 3 specific mistakes to avoid. First, a very frequent error is confusing the value of n divided by 2 with the median itself. It is easy to see that number 20 in our previous example and think, that's my answer. But remember, n divided by 2 is simply the position of the median in our data set. It tells us which observation we are looking for. The actual median is a specific value that lives somewhere inside that median class we identified. Second, be careful not to select the wrong class. I have seen many students look at the cumulative frequency table and pick the class where the cumulative frequency is closest to n divided by 2, but still slightly smaller. For instance, in our example, you might be tempted to pick the 10 to 20 class because 12 is close to 20. However, you must be disciplined. You must pick the very first class interval whose cumulative frequency meets or exceeds n divided by 2. Finally, never skip the cumulative frequency step. It might be tempting to try and find the middle by just looking at the individual frequencies, but that won't work because the frequencies don't tell you the running total. You cannot identify the median class by looking at the frequency column alone. You must always calculate the cumulative frequencies first to see where that middle point actually falls. Keep these tips in mind, and you will be well prepared for our next step, where we will learn how to use this median class to calculate the exact median value. Key takeaways. First, remember that the median class is not just a single number, but the specific interval that contains the middle observation of your entire data set. Second, the most critical value you need to calculate for your identification process is n divided by 2. This value tells you exactly which position in the data set we are searching for. Third, when you are looking through your table, remember the rule. The median class is the very first class interval where the cumulative frequency is greater than or equal to n divided by 2. As we saw in our student test score example, we don't stop at the value just below our target. We look for the first one that meets or exceeds it. Finally, keep in mind that identifying this class is a vital prerequisite. You cannot jump straight to the complex grouped data median formula without first locating this median class. Mastering this step is the foundation for the more advanced calculations we will perform in our next session. To wrap up our lesson today, let's review the key takeaways to ensure you have a solid grasp of this concept. Great job today, and I will see you in the next lesson.